We are learning to use combinations to solve problems. And we do this by example. Now I'm going to do an example. I'm going to do this example in two ways. Okay, so fruit salad can be made with 5 different fruit. We have grapes, peaches, apples, pineapple, and oranges. How many of ways can the fruit salad be made? Now I didn't say we have to use one or the other. We don't have to use any of them. Sorry, we have to use one of them, but we could make a fruit salad with, just grapes. If one fruit is chosen, I could choose grapes. I could choose peaches. I could choose apples, pineapple, or oranges. I could choose one of them. So 5 choose one ways. If 2 fruits are chosen, I have 5 choose 2 ways. If 3 fruits are chosen, 5 choose 3 ways, etc., etc. Now what this all works out to is I add up all my cases and I work out the math, or I do it in a calculator. This is 5 choose 1. This is 5 choose 2. This is 5 choose 3, etc., etc. You see the pattern. And that works out to 5 ways, right? So there's 5 ways we can choose one fruit, 10 ways we can choose 2 fruits, and 10 ways we can choose 3, 5 ways we can choose 4. Think about it. If we're choosing 4, we're leaving out 1, right? So it's the same as picking 1. And then 5 choose 5. If I'm choosing all 5, there's only one way to do that. That's 1. Okay. And if I add them all up, it equals to 31. And that's my answer. There's 31 ways to make this fruit salad. Now I'm going to try and remember this 31. We're going to do it in a different way using the indirect method. Now, there are 5 fruits. We can either choose to use it or not. So if this is grapes, and this is peaches, and this is apples, and this is pineapples, and this is orange, we have a choice. We can either use it, use, or not. We can either use or not. We have 2 choices in each case, use or not. So in each case, we can either use it. We have 2 choices, to use it or not use it. Now, that is a total of 32 cases. Now, if you think about it, that includes the case where I don't use it. I use not. I don't use it at all, which is not a fruit salad at all. I use none of the fruits. So that includes a way, that one way. So one of those situations includes where I choose not to use any fruit. So I subtract that case. Okay, these are all cases. And I end up getting 32 take away 1. Total minus the one way is 31 ways to make a fruit salad. And I end up getting the same answer as I did in the previous example. Okay, so we have a game of Euchre, and it only uses part of the deck, right? It only uses 1, 2, 3, 4, 5, and 6. 5 cards are dealt to a player. How many Euchre hands contain at least 3 queens? Now, if I have 3 queens, that means I have 3 queens or 4 queens. A hand with 3 queens, Q, 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 is different from a hand with 4 queens. So I'm going to add up the cases. So there's only 24 cards in this deck because there's 6 different cards with 4 suits each. And how many ways are there to choose my 3 queens? Well, there's 4 queens. There's 3 ways. You can choose 3 of them. And there's 20 other cards. So 24 cards. I'm going to choose 2 from the 20. How many ways can I do that? Now that is 4 choose 3, and that is 20 choose 2. Now 4 choose 3 is the same thing as, if you think about it, I'm not including 1. How many ways are there to not include 1? Well, the answer is 4 ways, right? Because there's 4 cards that I can not include. And now this works out to be 190. If you just put it in your calculator, you'll see that it does work out that way. In fact, you don't even need a calculator. It's 20 times 19 times 18 times dot 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 times 2 times 1. And here we have 2 factorial, and we have, what do we have here? We have 20 minus 2, which is 18 factorial, which is, crosses that out. So it's 10 times 19, which is 190. So you can do the math quickly. You can use your calculator. It really doesn't matter. At that point, there's 760 ways to select 3 queens. Now, how many ways are there to choose 4 queens? Now, if you think about it, there's only one way. As soon as I select it, if you put this in your calculator, you're going to get equal to 1. And there's 20, choose 1. 20 cards, I'm choosing one of them. I have to choose one of the 20. So I'm just going to work this out. This is what 4 factorial over 4. You'll do the math and you'll see that. If you do the math, 4 factorial over 4 minus 4 factorial over 4 factorial. Now this works out to 0 factorial, which is equal to 1. And this just crosses out and it's equal to 1. The same is true here. We have 20 factorial over 19 factorial. We're left with only 20. So the answer is 20 ways to select 4 queens. And finally, we have 760 plus 20 ways. So 780 ways you can select at least 3 queens. Example 3. In a game of hearts, the entire deck of cards is dealt. You have a hand with 13 cards. In how many ways could the hand contain at least 2 hearts? So at least 2 hearts, that means I could have 2 hearts. That's one case. 3, 4, 5 hearts, 6, 7, 8, all the way to 12 and 13 hearts, right? So I could do that and do about 11 cases. Or I could find out how many total ways there are. And subtract that, the number of ways to select 0 hearts and 1 heart. So we're going to use the indirect method. So how many ways are there to select no hearts? There's 52 cards in a deck. Well, I have 13 hearts. I'm going to choose 0. And there's 39 remaining cards. How many ways are there to select 13? So we have, that's going to work out to 1. You'll see in a second. And 39 factorial, 39 choose 13. It works out to that. It's 1 times about 8 million here. Case 2, how many ways are there to select 1 heart? Well, I have 13 ways. There's 13 hearts. I can choose them in 13 choose 1, which is going to equal to 13 later. But I work it out here. Whoa, that's supposed to be 13 minus 1. And we have 39 factorial, 39 minus 12 over 12 factorial. And we have 13 times about 3 billion. Oh, did I say 8 million? Looks like it's 8 billion. So we have, about 51 billion. Okay, so I have my case 2. The total ways to select 13 hearts from 52 is 52 choose 13. Take away that number. Take away the number of ways to select 0 hearts. Take away the number of ways to select 1 heart. By the way, it's 635 billion. And you get the total ways to select at least 2 hearts. So we end up with 576 billion combinations of selecting at least 2 hearts. Okay. Moving on. Example 4. How many 5-letter codes can be formed from 2 different vowels and 3 different consonants? Consider Y a vowel, always. Okay, so how many 5-letter codes can be formed if you select choose, then arrange? So this is a choosing and then arrange. So once we choose, How many ways? We multiply that by the number of ways to arrange it. So the number of ways to choose 2 different vowels. And then we have number of ways to choose 3 different consonants. So it's 6 choose 2. So 6 comes from A, E, I, O, U, and it says consider Y a vowel. So then there's 6. And then there's 20 consonants. That's just 26 minus. There's 26 letters, 26 minus 6. And we're choosing 3 different consonants. After I choose my 5 letters, once I choose my 5 letters, I have 5 letters and different letters. How many ways are there to arrange it? Well, there's 5 factorial ways to arrange it. So you multiply 6 choose 2, 20 choose 3, multiply that by, okay, these are the number of ways to choose 5 cards. Then once we choose them, how can we arrange them? 5 factorial ways. So that ends up equaling 15. 20 choose 3 is 1140. 5 factorial is 120. And there is about 2 million ways, or 2 different 5-letter codes that can be formed in that way. Okay, so here are the key concepts. The total number of subsets of a set n elements is, okay, so subsets of n elements. So if I have n elements, right? If I have these elements, right? I have 5 elements. Well, I could choose 1, right? I could choose 2, right? I could choose 3. I could choose 4. How many ways are there? And I could choose 5, right? I could have 5 in a subset. But I'm not sure. They could all be different, right? And I could have 0 in the subset as well. So, it's not 2n. It's actually equal to n squared. Okay? In some cases, the null set is not considered. In such cases, we have n choose 1. So in what are we talking about here? Right? We're choosing, just like the salads, right? 5 different fruits. So n equals 5. We had 5 choose 1, 5 choose 2, ... up until we got to 5 choose 5. I'm not sure why this is formatting to this, in which case it's 2 to the n minus 1. Oops, sorry, not 2 to the n squared minus 1. Okay, consider using the indirect method, especially if it involves fewer cases, such as when you need to choose at least one of 2 items. By the way, we had 5 cases, right? So n equals 5. My mistake, it's 2 to the n minus 1. My mistake, I keep messing that up. I apologize. Which is 32 minus 1 cases, which was 31 if you remember. Okay, if the order is important, consider selecting the items first and then arranging them in order. Okay, so this is your homework. Page 120 to 121. These are the questions. That's it. Thank you.